Hello, hello, hello. Welcome to the Golden Path to SpringOne. I'm your host, Whitney Lee, and I'm also your guest, Whitney Lee. I'm your ghost. That's I'm so glad to have everyone here. We have Anjan here in the chat. Thank you so much. Joining from Bangladesh. Anjan, I'm in Austin, Texas. Isn't this a wild world that we get to hang out from literally across the planet in real time? It's super cool. Streaming is amazing. I'm going to talk to y'all. Oh, we have someone here. Ashraf's from Egypt too. Super cool. I'm going to take some time. I'm going to talk to you about Kubernetes today. But before I do that, I want to establish trust. I want to help you know why you should trust me to teach you about Kubernetes. We have Abhishek here from India too. Hi, Abhishek. Oh my. And Harnor too. Hello, hello, hello. I'm so glad to have you. I'm a developer advocate here at VMware Tanzu. I'm also a CNCF ambassador. We also have people here from France, the Dominican Republic. Ritesh is here too. Hello, Whitney and everyone. I'm both. I am Whitney and everyone today. Well, I guess everyone is all the friends in chat. I'm so happy that y'all are here. This feels really great. I recently got elected to be a CNCF ambassador. I gave a keynote presentation at KubeCon. Flame of Shadows here and says, hi, ma'am. I'm in fact going to brag a little by putting some links in the chat. So I'm a developer advocate at VMware Tanzu, and I host another show on the same channel, and it's called Enlightening. So you can see the light board that I have in the background. Kubevela is going to be the episode that we do on Thursday. For my Enlightening show, someone will come on and teach me about a project, usually a CNCF project. CNCF are the tools that build on top of Kubernetes. CNCF stands for Cloud Native Computing Foundation. We have Abukar here from Pakistan. Welcome, welcome. So that's one thing I do is I host that show. I'm the co-host of another show called You Choose. That one's on the DevOps Toolkit YouTube channel. That one I co-host with Victor Farsik, who runs that YouTube channel. So for that one, we do a choose your own adventure style journey through the CNCF landscape. Our first chapter was taking an application from a developer's laptop all the way through to a development environment and all the different system choices that need to be made along the way. For example, the first episode was about choosing a strategy to build your container image. And then we bring on guests from different CNCF projects that do that. So we brought in guests from Kbuild, from Cloud Native Build Packs, and from Lima that uses BuildKit under the hood. We let them present each for 5 minutes, and then you, the audience, gets to choose which technology we build into the ongoing demo. So that's that one. If you want to, and then Victor and I are also doing a talk at KubeCon that is called Choose Your Own Adventure, and it's based off of that same concept of choosing our way through to development. Although we plan on doing it for some years, probably. We hope to hit every single CNCF project, but new ones keep getting added. Not to mention there's already between 150 and 200 to start with. New ones keep getting added. So I'm not sure we can make them fast enough to keep up with all the projects, but we're certainly going to try. Also at KubeCon, is anyone here going to be at KubeCon in Amsterdam? If so, please say hello to me if you see me around. Another thing, I'm presenting there at the Cloud Native Rejects, and there I'm presenting about Kubernetes admission policy and how to set that in a wise way. And then finally, just more stuff about me. This is just my bio. It has like an interview and a link to the KubeCon keynote. But that's a lot of stuff. Do you trust me yet to teach you about Kubernetes? I hope so. So what I'm hoping today, well, honestly, I don't want to bring my ego into this. What I want is to be water that fills the vessel that is this Path to SpringOne show. So I have a presentation prepared. I'm going to do that presentation. It's slides. I'll put those on the screen soon. But I want, if it's something where I'm talking to you and there's not much interaction, that's fine with me. But if it ends up wanting to be more like a discussion and y'all have a lot of questions, I'm really great with that too. So as I'm talking, as you have questions, please do put them in the chat, and I am able to watch the chat while I present, and I'm happy to speak to your questions as we go. I think that'll be more fun to have more of a conversation than to just do all of the questions at the end. Flame of Shadow is from Bangladesh. This is super cool. Thank you so much, everyone who's here. I'm so honored to be doing this with you right now. So give me a moment to get my stuff set up. So I'm going to get this into present mode. I'm gonna just by there. That's my wallpaper. I thought it'd be funny to make my computer wallpaper look like actual wallpaper. All right. Now we should have slides. Excellent. So the presentation today is who should use Kubernetes. So the idea for this talk started when a question that my developer friend asked me, who is Kubernetes for? And this happened maybe a year and a half ago. So at that point, I was surprised to realize, like, oh, I don't know exactly. I mean, I know Kubernetes is great to optimize costs and to streamline operations for like enterprise size organizations. And I know that Kubernetes is likely overkill for like an app that someone's building on their own as a side project, but I didn't know about in between. Like, at what point do the benefits of Kubernetes outweigh the operational complexity? What factors might an organization consider when deciding whether to adopt Kubernetes? So my name again is Whitney Lee, and among other things, I host a streaming show on Tanzu TV called Enlightening. So each week, a guest comes on the show and teaches me a cloud-related concept or technology, and I draw out the information on my light board as I learn. Hello, Nick, the first one. I'm so glad to see you here. I ask tons of clarifying questions as we go, and it is a streaming show, so we always get a lot of great questions and comments from chat members, such as Nick the First One, who just joined. Nick the First One is, true to his name, one of the first ones who started coming to my show regularly. So it's really special that you're here now, Nick. Anyway, so thank you so much again for being here. And this experience of my friend asking me who's Kubernetes for is what led me to make an enlightening episode called Who Should Use Kubernetes? So for this show, I invited my talented teammate, Lee Kapili, to be my guest to come on the show and help answer some of these questions. So Lee and I had a super fun stream where we discussed Kubernetes. We heard a lot from chat about their experiences, including a literal server fire, and the episode ended with Lee doing a cartwheel. So this is the starting off point for my talk today. And the question we want to answer is, who should use Kubernetes? But before we talk about the who, let's discuss the what and the why. But before we do even that, time today is limited, so I'm going to declare some topics off limits. So first of all, we're not going to define Kubernetes as a container orchestration platform. I mean, granted, it's an absolutely valid way to describe Kubernetes, but that's not how I'm going to talk about it today. We're not going to talk about cost optimization. Cost optimization is a big benefit of Kubernetes, no doubt about that, but don't you dare mention it. Using Kubernetes will help to make your applications fault tolerant, partly because it automatically restarts failing containers. But you're just going to have to take my word on that one, because now is not the time to discuss it. Kubernetes scales applications based on resource utilization, but don't ask me anything about it. We're not going there. In fact, here's a bunch of other stuff that's just off limits. We're not covering it. That is not the point of today's talk. Right now, I'm going to talk about an often overlooked benefit of Kubernetes, and arguably the most important one, the big idea. But before I do, what is Kubernetes besides a container orchestration platform? Kubernetes is software that knows how to run software. Kubernetes is software that knows how to run your containerized applications. Kubernetes is distributed. So that means Kubernetes has one interface, yet it runs across multiple computers at once. With Kubernetes, you can turn lots of computers into one cohesive idea. Kubernetes is also declarative. So you define your system's desired state, and Kubernetes works to bring that state into being. So in doing so, Kubernetes stores your way of working. So let's say it again for those in the back. For the purpose of this talk, this is how I'm defining Kubernetes. Kubernetes is a distributed, declarative software that knows how to run your software. So keeping that definition in mind, here it is, the big idea, the often overlooked benefit of Kubernetes and one of the most important benefits. Kubernetes helps people work well together. I'm going to take a moment to say hi to some folks in chat. Nick, the first one, thank you. Always a pleasure to have you in the chat, Nick. And I like your slides. Thank you. I've hand drew all of my slides. I actually am a career changer. So I switched my career. I used to have an art-related career, and now, of course, I'm in cloud computing. And Simon's here too. Hello, Simon. Thanks so much for coming. And we have a hello from Dubai. Hello, Walid. All right, let's keep going with the presentation. So, Kubernetes helps people work well together because it provides a consistent, repeatable, cloud-agnostic way to define the building blocks of your system. Kubernetes creates clear separations of concerns. People who use Kubernetes can understand how the parts of the system that they touch relate to other teams and relate to the system as a whole. And Kubernetes' standardized way of working creates a vibrant ecosystem of tools and best practices across organizations. Okay, I've been going on about declarative, but to help understand what problem a declarative way of working helps to solve, let's talk about the opposite of declarative, imperative. To illustrate imperative versus declarative paradigms, let's consider a scenario where you ask me how to get to the library. If I answer imperatively, I would give you a series of steps as the answer. Step 1, go west on Riverside. Proceed for 2 miles. Step 2, turn right on Congress. Proceed for 2 blocks. Step 3, turn left on 2nd Street, and the library will be on your left. This is all very sensible, but it's also highly dependent on circumstances. What if you go to the lunch before going to the library? These directions are no good without the proper starting point. What if Congress Avenue is closed for construction today? You're left with no recourse. So if you ask me how to get to the library and I give you a declarative answer, I'd simply give you the address to the library and a map. It would be up to you to choose the best steps to take given your circumstances at the moment. Okay, Whitney, you've convinced me. I understand that imperative is inferior, but what does an imperative system look like in practice? I'm going to answer that with one word: scripts. Imagine that you're in charge of creating and maintaining environments that host applications. You need a consistent way to install apps and their dependencies on several different computers. Before Kubernetes, the answer to this problem was big, long bash scripts. Scripts to install operating systems, scripts to install applications and their dependencies, scripts to configure the environment. If the server restarts, scripts are needed to restart all of the applications that should be running, and then more scripts are needed to make sure that everything restarted correctly. If the script gets changed, how do we reliably update that script across the entire estate? What happens when a vulnerability is discovered? What happens when web traffic grows and you need to scale up? One way to imagine how difficult and how tedious this must be to be an operator of a system that's run imperatively is to imagine that you're in charge of making sure that two laptops are exactly the same, and you're also in charge of keeping them exactly the same indefinitely. Did you install and configure software on one? Do the same for a second. Did you change permissions on the first laptop? Did you update which apps you want to be able to notify you and how? Make sure you're capturing all of that and making those adjustments on the second laptop too. I get it. Kubernetes is awesome because it's declarative. But wait, what does declarative mean? What does a declarative system like Kubernetes look like in practice? I mean, I understand that with Kubernetes, you define the desired state of your system, but what is being defined exactly? Defining the desired state of your system sounds really broad. How is the state of your system being defined? And who's in charge of defining it? It seems like a tall order. The desired state in Kubernetes is defined using Kubernetes resource objects. Side note here, you can hear these are often called resources. They can be called objects. If they're outside of the Kubernetes canon, they can be called custom resources or custom resource objects. You can hear this concept described in many terms. I'm going to say Kubernetes resource objects or resource objects throughout this whole talk. So Kubernetes resource objects are persistent entities in the Kubernetes system. So Kubernetes uses these entities to represent the state of your cluster. A Kubernetes resource object is a record of intent. So once you create the object, the Kubernetes system will constantly work with control loops to ensure that the object exists. By creating an object, you're effectively telling the Kubernetes system what you want your cluster or its workloads to look like. So this is how you define your cluster's desired state. So if you're a developer, you're likely interested in Kubernetes resource objects that most closely touch your running application. So here's a quick overview of some of the Kubernetes resource objects that are used to define how a containerized application is to be run, accessed, and configured by Kubernetes. So you can define how you want to do scaling, rolling updates, and rollbacks in a Kubernetes resource object called a deployment. Within a deployment, a replica set resource object is where you define how many instances of your application you want to be running at any given time. A pod is the Kubernetes resource object that is the smallest unit of compute in Kubernetes. And a pod hosts your running application. So that little blue square is your running application. But at this point, the running application isn't accessible unless you're able to identify which machine it's on and then SSH onto that machine and you know your pod's IP. That's not realistic. So we need a service Kubernetes resource object. It provides one stable endpoint that you can use to access one or many pods that are running your application. But that only provides access from within your cluster. To access your application from outside of your cluster, you need a Kubernetes resource object called an ingress. You can define configuration for your pods with the resource object called a config map, and define secrets for your pods with the Kubernetes resource object called a secret. Cleverly named. So those were resource objects that you're likely to encounter as a developer, but there are many more. I'm going to rattle off a pile of commonly used Kubernetes resource objects, but don't worry about remembering them. The point here is to show you examples of many of the different aspects of your Kubernetes system that are getting defined using these Kubernetes resource objects. So namespaces are used to provide isolation between different projects that are sharing the same Kubernetes cluster. Persistent volumes represent pieces of storage in the Kubernetes cluster. Limit range objects provide constraints to limit the resource consumption of pods or containers. But then you also have resource quotas that constrains the aggregate resource consumption of all the Kubernetes resource objects in a namespace. Network policies are specifications of how groups of pods are allowed to communicate with each other and then with other network endpoints. Roles contain access permission rules, and role bindings grant those permission rules to a certain set of users. Nodes are worker machines in Kubernetes, computers. These can be virtual or physical. And then service accounts provide an identity for processes that run in a pod. Pod security policies enable fine-grained authorization of pod creation updates. And there are many more. There are lots of types of Kubernetes resource objects. There are over 50 in the most recent release of Kubernetes, and there are many more, thousands more when you consider objects that you can make with other open source projects in the Kubernetes ecosystem. So I mentioned I'm a CNCF ambassador. So CNCF gives oversight for all of the projects that can run on top of Kubernetes. You can hear them referred to as just projects or Kubernetes add-ons, or they're the ones who make these custom resources, which are Kubernetes objects that are running, that are made by a third party, not by Kubernetes itself. But the point right now is that Kubernetes provides a way to declaratively define a lot of different aspects of your applications and of your system. So Kubernetes resource objects fall under 5 umbrellas. The workload Kubernetes resource objects are responsible for managing and running your containers on the cluster. So that's objects like pods, jobs, deployments, stateful sets, and replica sets. That all falls under this category. I'm watching the chat too, so if you have any questions, don't be shy. I feel like I'm throwing a lot at you. The service Kubernetes resource objects are responsible for stitching your workloads together and for making them accessible to traffic. So objects that fall into this category are services, ingresses, and endpoints. Configuration and storage Kubernetes resource objects are used to create resources that are responsible for injecting data into your applications and persisting data externally to your cluster. So some examples of this are config maps, secrets, and volumes. The Kubernetes resource objects that fall into the metadata category are responsible for configuring the behaviors of resources within the cluster. So for example, horizontal pod autoscaler for scaling workloads, limit range for limiting the resource use of containers in a namespace, and pod disruption budget for specifying how many replicas of a given workload can be made concurrently unavailable while performing maintenance. So that's a pretty granular specification right there, but I think it helps to make the point. And again, as a developer, the idea isn't for you to understand all of these. It's more just to understand a big picture of all the different ways things are defined within Kubernetes. The ones that you'll touch were the ones we talked about before. But finally, we have Kubernetes resource objects that are responsible for defining the configuration of the cluster itself. So here we have objects such as namespaces, roles and role bindings, service accounts, and network policies that we mentioned before. So, do you remember the big idea? That Kubernetes helps people work well together? Well, specifically, Kubernetes resource objects are integral in helping people work well together. Why is that? Well, Kubernetes resource objects help to create a separation of concerns, and also a standardized way of working among people and teams who do share concerns. Different people within an organization care about different Kubernetes resource objects, and there's some overlap, as you'll see. A site reliability engineer is in charge of making sure that things are working for our end users. They care about Kubernetes resource objects such as network policies, roles and role bindings, namespaces, and horizontal pod autoscalers. We have a question in the chat right now. The question is it possible to communicate to pods? So I'm not quite sure what you mean, but I want to say probably yes. You can, if you want to have pods be able, like one pod is hosting your backing service and one pod is running your application, you can absolutely wire those together so that they're able to work together. You can also use service mesh. Service mesh is when there's a container. So your pod is the smallest unit of compute in Kubernetes, and inside of your pod is your running application. Service mesh is when you add a second container in every single pod, and that second container is the service mesh, and its job is to make every pod be connected to every other pod. And so that is a kind of a heavy thing to do in terms of the amount of compute that you're using, but it's definitely a way to enable fine-grained communication between all of the pods in your cluster. Thank you for the question. I like to know that y'all are out there and I'm not just talking into the void. Okay, let's just jump into, also we have a nice comment from Mohammed, how easy, it's easy to, I'm trying to use the wrong, that it's easy to understand me. Thank you so much. I'm glad. I'm a pretty new learner. I mentioned I'm a career changer. So I made this presentation a while ago, but it's something that helps me understand the big picture of Kubernetes because it's a big thing to wrap your head around. 97 says no need for scripts. Oh no, I like scripts. I'm sure you could find some ways to use some scripts. I doubt they'll ever fully be dead, but I think it's better to have a declarative way to define what you want to be happening. The stylish thing to do in the cloud computing space, at least, is to use a declarative method and then store those declarations in Git, and then use GitOps to reconcile your Kubernetes resources with what's defined in Git. So that's instead of using scripts, you have a declarative way that you know what's running. And then if for some reason your cluster goes down, or if you, like for a development environment, if you're using GitOps, for example, when you're not developing, you can take that cluster down because you know exactly how to, your Git contains the instructions to spin it right back up again. So you don't have to always have a development environment running. What is the resource type for network policies? I don't know. Maybe the answer is I don't know. And the Kubernetes resource object is just simply called a network policy. I'm pretty sure, just all one word. But in terms of the type, I'm not sure the answer to that question. Oh, Nick, the first one says you could always create scripts that create Kubernetes file. There you go. Everybody's happy. And then we have a thank you so much. You're very welcome. Thank you for engaging with this presentation. It brings me joy. All right, let's move on to different roles and how they use the different Kubernetes objects. So next up, we have an infrastructure engineer that's responsible for provisioning hardware and installing Kubernetes. And that infrastructure engineer cares about Kubernetes resource objects such as network policy, nodes, and certificate signing requests. A database administrator cares about database instances, migrating data, expanding hard drives, and accessing data. They care about Kubernetes resource objects such as volumes, storage classes, persistent volumes, and persistent volume claims. A cybersecurity engineer cares about security policies, access and authorization, and providing identity to workloads. They care about Kubernetes resource objects such as pod security policies, service accounts, roles and role bindings, and ingresses. An application developer cares about the objects that I mentioned earlier, that we talked about earlier in the presentation, Kubernetes resource objects that touch the running applications, such as pods, deployments, services, and config maps. Before Kubernetes, developers used to just send the binary of their application to operations. Developers now feel closer to production because they understand how it will behave. As a result, they naturally adapt their designs for production. But what about the complexity? Kubernetes is notoriously difficult to install and maintain. The complex details of installing and running Kubernetes are increasingly being abstracted away. Many cloud providers offer managed infrastructure, also known as infrastructure as a service. With managed infrastructure, the cloud provider is responsible for servers, storage, networking, and you manage the layers on top, such as a running Kubernetes cluster. But if that's too much work for you, there's also platform as a service. Now, this is not to be confused with platform engineering, which is another stylish thing in the cloud computing world right now. By platform as a service, I simply mean Kubernetes itself as a managed service. So these days, you could set up an initial cluster with a cloud provider in just a few minutes. With managed Kubernetes, your cloud provider is responsible for the Kubernetes control plane, as well as the server storage and networking that's provided with infrastructure as a service. It's true, I won't deny it, Kubernetes is complex. It may be hard to set all of it up, but it's worth asking yourself, what am I doing right now with my current system? Is setting up and using Kubernetes more complex than that? Kubernetes also has a vibrant ecosystem of tools and add-ons in the form of other open source software. So there's a lot, hundreds of tools that can be added to your cluster that help you do things like extract away complexity, add observability. You might add additional security features to your cluster with these tools, or tools that supercharge your storage or your messaging or your databases. You can add additional software to improve the areas of Kubernetes that are important to your particular business. So all of these tools, these custom resources, part of the CNCF ecosystem, or some of them are not, they all are built upon this Kubernetes resource model that we talked about earlier. So these tools, you define your Kubernetes resource, and then Kubernetes, you also make a controller so that Kubernetes can watch the resource to make sure it's always in the state that you declare that it's in. So these tools all work first by creating their own Kubernetes resource objects. Kubernetes is becoming mature, and best practices are emerging for common problems and issues. For example, use a software called Valero for making backups of your Kubernetes clusters. You don't need to worry about how it's done. The open source communities have already figured it out. Or you could use a tool like Crossplane that leverages the Kubernetes resource model to enable you to define and spin up physical infrastructure across cloud providers in a Kubernetes way. So with Crossplane, you can use that Kubernetes model of having a resource object with a controller, but you can use it to manage infrastructure that's completely outside of Kubernetes, or even other service providers like a Salesforce or something that's completely outside of Kubernetes. It's pretty cool. We have hello from Jamil. Good to see you. And Nick, I'm not sure if I say yes, am I screwed? I'm not sure what that's in reference to. All right. So we have community best practices in Kubernetes. And so Kubernetes helps people work well together. So it helps people work well together because Kubernetes provides a consistent, repeatable, cloud-agnostic way to define the building blocks of your system. Kubernetes creates a clear separation of concerns. People who use Kubernetes can understand how the parts of the system that they touch relate to other teams and relate to the system as a whole. And Kubernetes' standardized way of working creates a vibrant ecosystem of tools and best practices across organizations. So, okay, that all makes a ton of sense. But I still have another question. And this one is really important. Who should use Kubernetes? We've talked a long time and haven't even touched this question. Here we go. Are you having issues because there's a mismatch between your production and development environments? If so, you should use Kubernetes. Developers can use Kubernetes in their development environments, and in doing so, they'll have a better understanding of how the production environment will work. Are you suffering from not having a standardized way to communicate across teams, resulting in operational toil? If so, you should use Kubernetes. If you use Kubernetes, no matter in which language your application is written, it's configured using the same mechanisms. For example, both developers and operations teams use that config mapped object to set and tune an application's configuration. We have, Nick said so I asked what Nick was referring to with this comment. If I say yes, am I screwed? And Nick says that it's more difficult to set up Kubernetes than what we're doing right now. Nick, the first one, it might be worth it switching over. And then we have another friend. Hello from Pakistan. All right. Is your infrastructure complex and difficult to manage? If so, you should use Kubernetes. The Kubernetes ecosystem has many tools to help with infrastructure standardization, tools that codify and version your infrastructure. For example, Argo CD and Flux CD. And we're getting again into GitOps land right there, which is stylish here in my world. When your applications need to scale, is the process slow, complex, and risky? If so, you should use Kubernetes. Kubernetes helps to automate scaling using resources like the horizontal pod autoscaler, or an open source software, a Kubernetes add-on called Knative further improves this process. Do you feel locked into your cloud provider because it would be too complex to move? If so, you should use Kubernetes. To make your system cloud agnostic, you can rely on the Kubernetes APIs instead of using cloud provider tools. Does your company's operational knowledge exist only in people's minds? I know a lot of people can relate to this one. If so, you should use Kubernetes. The Kubernetes resource model helps you to define your operations in a concrete and standard language. It's common practice to store and version this knowledge in Git. So formalize the knowledge and keep track of it. And we we have a question: who should not use Kubernetes? That's a great question. There's probably a small enough operation where the cost of the infrastructure needed to run Kubernetes itself outweighs the benefit that you would get. But even if you think it's going to grow, it still might be worth starting with Kubernetes. I've definitely heard of startup situations where it's a matter of getting it up faster too, and that'd be a point maybe you just want to do the fastest thing and the most lightweight thing because speed is a big issue for you. We have a hello from Amsterdam. Hello, Sri. Nick said, I said yes to all of the questions, but still haven't found a way to integrate Kubernetes yet. It's fair. That's a big problem. And we have Batwan. Thank you so much for coming, Batwan. Have a great show. You're doing great. Thank you. Thank you. And have a thank you. Yay. Y'all are the best. This is also when you don't own a lot of the infrastructure, that might be a good time to use Kubernetes. Not to use Kubernetes, it's according to Nick, which I think is a good point. All right, so in conclusion, an often overlooked and very important benefit of Kubernetes is that Kubernetes helps people work well together. So for that reason, any growing organization should at least consider incorporating Kubernetes into their operational model. That's the end. Thank you so much for your valuable time and attention. And feel free to stay and we can chat a little bit. If you like, follow me on Twitter. Please do check out my show Enlightening. Come hang out during that stream. Y'all have been a really fun crowd. So I hope you come see that one too. It's a lot longer of a format, but we have a great time. And you all ask really good questions. I appreciate that. I'm going to close this. I'm going to put my big face back on the screen. Remove my, here I am. Look how huge I am right now. It's intimidating. If anyone is going to be at KubeCon, please do find me. I do have some who should use Kubernetes stickers. Let me get, there they are. Look, it's a sticker. So if you're at KubeCon, let me know and I'll give you one. I try to only give stickers related to a talk to the people who have seen that talk. So I won't be advertising that I have these. You have to have seen the Who Should Use Kubernetes talk to get a Who Should Use Kubernetes sticker. Also, I have huge Enlightening stickers. So if you come to an Enlightening stream and you see me really ever at KubeCon or anywhere, I have Enlightening stickers. But again, you have to come to an Enlightening stream. And similarly with the You Choose show, I have You Choose stickers. You'll just have to take my word on it. So I think it's over. So I have some closing remarks. Do y'all want another link to? I'll just put in one link to stuff I'm up to. The You Choose stuff isn't here, but if you go to the YouTube link here, then you can find my You Choose show. So I have, but the link to Enlightening episodes is definitely in that link. And then we have some SpringOne stuff to talk about. There's a SpringOne Academy. So check that out. You can register for free at that spring.academy. Oh, they make it nice and easy to remember. I like that. And I'm going to keep looking at the comments for just a little bit before I do the goodbye stuff. I actually just lost track of the... So I think with that, friends, I'm going to say goodbye. This has been an absolute joy. It went by in the blink of an eye, didn't it? Thank you so much for having me and for your valuable time and attention. I'm honored that you decided to spend it with me. And I hope that I see you again in real life someday, or even in streams. I hope we can make a virtual friendship, or a real one, or both. Okay, let's close this out. Wait, says Nick, the first one. Okay. I didn't want it to end. We have a thanks for the session. And Nick, the first one, says, wait. But it's getting a little awkward. Do we still have an enlightening episode on Thursday? We do. So we're going to talk about Kubevela on Thursday. And so Thursday's stream, let me just get here. I'm just going to link you to the whole enlightening page, and then the details for the Kubevela stream are right at the top. And what I do when I want to see a stream is I'll click on the YouTube link, which is there in that taju.tv enlightening. So keep on upcoming episodes, then click the YouTube link, and then there's a place to do notify me. So click the notify me button there. And that's great. So thank you. I appreciate everyone's time, and it's time to say goodbye. Have a wonderful, wonderful week. All right, goodbye. Oh wait, please come see us at VMware Explore in Las Vegas. Get some stickers from me then. All right, so we're doing the thing. Goodbye, everyone.